Hey everybody, welcome to Beyond the Model episode 2. I am Kieran Haynes and I am your host today. So, Beyond the Model is an AI and machine learning community for anybody interested in either of these topics globally, where we talk about the most pressing and interesting issues in AI. Today, we are joined by my good friend Mutlu Dogruel, who is the VP of Artificial Intelligence at Cresset Drug Discovery. And we are going to talk about AI, drug discovery, as well as some of the more interesting philosophical topics like AGI. So yeah, Mutlu, welcome. How are you?
Thank you, Kieran. Pretty good. Hi, everyone. It's a pleasure to be here. My name is Mutlu, and I have indeed the exciting role of being the Vice President of AI at the Cresset Group, leading the strategy, weaving it into our products, and heading up a team of seriously smart folks who are just as AI obsessed as I am. So my journey to this point, to talk about the highlights, it's been a wild ride. After a deep dive into the world of physics with my bachelor's degree, I shifted gears and I got hooked on the digital side of biology. I earned my PhD from University of Cambridge and the Sanger Institute in Bioinformatics, where I had the privilege of collaborating with some of the most brilliant minds in bioinformatics. Before joining Cresset, I had quite an adventurous journey in the tech. I spent about 8 years at Microsoft UK, being a pharma AI architect. That was an incredible learning experience for me. Prior to Microsoft, I got my hands dirty with genomics pipelines in the biotech software industry. Before that, I dabbled in the art of speech recognition at HPE Autonomy. These experiences, along with my undergraduate degree in physics and my master's degree in biotechnology, really set the stage for my career. They were like the launchpad that propelled me into the orbit of AI, cloud computing, and ultimately into the innovative universe of Cresset. At Cresset, we specialize in cutting-edge computational drug design software and services. Our tools like Flare for CAD is computer-aided drug discovery, and Torx for DMTA, design, test, make, analyze, are widely used in the industry and academic circles. What's truly exciting is how we are now weaving AI into all these areas to push the boundaries of what's possible in pharmaceuticals and agriculture. And when I'm not in the AI trenches, you might find me chasing the horizon as a private pilot, as I hold a PPL license. And also, you can potentially find me channeling my inner Federer on the tennis court, still working on that serve, by the way, work in progress. So that's a bit about me and what I do at Cresset. I'm genuinely passionate about the work we are doing and super excited about the future of AI in drug discovery. Thanks for having me, Kieran, and I can't wait to dive into our conversation.
Thank you, Mutlu. That was it's an absolute pleasure to have you here. And for anybody that isn't wildly familiar with AI in drug discovery, I'm sure you will be much more so at the end of this. But it's one of the most exciting areas just thinking technology generally, with the sort of implications and the places we can reach. So, to have an expert in this field here with me today and with us on Beyond the Model is fantastic. So going into this, talk to me, Mutlu, about AI foundation models and the generative AI trends currently.
So, what exactly are AI foundation models? Imagine a model that's trained on a vast amount of unlabeled data, speech, images, text, allowing it to be adapted to a multitude of tasks. These models like ChatGPT, GPT-4, and others form the backbone of many of the latest AI breakthroughs. They capture the general patterns and structure of data, essentially replacing the need for specific models tailored to individual tasks. Okay, these foundation models like ChatGPT are like the brainy kids in school who could pick up a textbook, flip through it, and suddenly they are acing tests in every subject. My son, who is 7, for example, started to finish his maths homework in like 2-3 minutes, the whole homework. Why? Because he loves Minecraft. So, it means that if he finishes his maths homework, then he can allocate more time to Minecraft. He is pretty much like the foundation models, spits a reasonable response to your question in seconds, right? And they are also quick at learning, right? And they can be fine-tunable just like your child. Now, here's where it gets really interesting. These foundation models are multimodal, meaning they can understand and process text, images, audio, video. And this is a game changer because it eliminates the need to develop separate machine learning models for each type of your problem. For example, instead of having one model for question answering and another one for object recognition and yet another for information extraction, a single foundation model can handle all these tasks efficiently. Mm-hmm. Okay. Now let's talk trends. Trend-wise, it's like fashion. What's hot today might not be tomorrow, especially in the fast-paced AI, space. But right now, here's the scoop: multimodal generative AI solutions are all the rage. It's like having a smartphone that does everything from calls to photos to managing your smart home. We already talked about that, and this is one big trend: multimodal models. Mm-hmm. Then we have smart language models, SLMs, and they are popping up everywhere.
Yeah.
They are like the compact cars of AI, zippy, efficient, easier to park in tight spots, right? If you can't afford to hosting the latest Llama model, 405 billion.
They're expensive, right?
Which requires lots of GPUs and lots of memory. Mm-hmm. You resort, to using SLMs. Autonomous agents are growing up fast, and autonomous agents are my favorite trend amongst the Gen AI trends. These are like, continuing with the car analogy, self-driving cars, but for digital tasks. And not only that, they can be specialized at specific tasks, but they can also talk to each other, converse with each other to solve complex hierarchical problems. And I think this is amazing, and we make use of them a lot. The next trend is open source. The race is on, and the gap between the high-cost, high-tech proprietary models and the DIY open source ones is shrinking, which is good. Yeah. Competition is good. And lastly, of course, let's not forget the bespoke suits of the AI world, task-specific generative AI products tailored to fit just right. For example, in chemistry, we started to see GPT-like models doing this and that, very specific tasks. By 2027, it's expected that over half of all Gen AI models used by enterprises will be tailored to specific industries or business functions. But this might seem like a contrasting fact, right? After all, aren't foundation models supposed to replace the need for multiple task-specific models? The key here is versatility. While major foundation models aim to consolidate capabilities into a single powerful system, the trend towards industry-specific models recognizes that different sectors have unique requirements. So in essence, these industry-specific models are built on the robust capabilities of general foundation models, but are fine-tuned for particular applications. This dual approach essentially ensures that the models are both broadly capable and highly specialized when needed. Right? And that was the last trend that I wanted to mention.
It's hard to understate the impact of generative AI. I think you can look at this in a vacuum, right? And you can think of it just in terms of how it's impacted the world of AI and machine learning and what that's led to. But I think if you just look, outside of technology as well, it's kind of been a bit of a watermark moment, right? Everybody knows what ChatGPT is. People that would never have interacted with those kind of technologies are now interacting with it daily. And it's a really, I think it's safe to say, being involved in generative AI right now is, that's a real pleasure, right? This is the time to be involved. So you must feel pretty excited about all of this stuff.
Exactly. I am, I think, at the right place in the right time, and I'm super excited about, doing AI in an extremely beneficial industry to our healthcare eventually, ultimately. When I first started at Cresset, the first thing to do for us was to, talk about the main strategy, to establish our main strategy. And our AI division now operates on 4 strategic pillars.
Yeah.
Maybe if I can talk about the top-down strategy for a bit.
Yeah, absolutely.
First, we integrate AI throughout the entire drug discovery lifecycle products, from initial design to development. And this not only boosts productivity, but also provides researchers with actionable, data-driven insights. For instance, imagine the benefits of predicting how a molecule will behave before even synthesizing it.
Right.
This kind of foresight is transformative for our customers, both in pharma and agriculture. And our second pillar is responsible AI.
Yes.
We are deeply committed to responsible AI. Technological advancements must go hand in hand with ethical considerations. We ensure that our AI models are transparent, fair, ethically sound. This is crucial in a field as impactful as biotechnology, where the stakes are incredibly high.
Couldn't be higher.
Yes, very, very high. Our third pillar is what we call DevOps for AI. This is also known as MLOps, LLMOps, depending on what technology you use, but essentially it's the adoption of DevOps practices when it comes to building AI and generative AI applications. We build and deploy AI solutions systematically, ensuring they are efficient, reliable, scalable, secure. This approach aligns perfectly with our broader digital transformation goals, enabling us to deliver robust AI-driven features seamlessly and consistently.
Yeah.
Consistency, I think, is quite key here. Lastly, that's our fourth pillar. AI isn't just for our customers or for our product features.
It's for you.
We use it internally to optimize our own processes, enhance productivity, and ensure smooth and effective operations. It's all about creating a culture of continuous improvement, where AI-driven insights help us refine our workflows, business workflows, whatever workflows we may have internally, and achieve excellence in everything we do. So how can AI help us with our, other goals, right? That's our fourth pillar.
So we're going to talk a little bit more about AI and drug discovery shortly, but I just think, just before that, so 4 pillars. What do you think has been the hardest one to really work on, the most challenging?
I think that's an interesting question. Thank you for that. I think generally speaking, the future of AI in drug design and drug candidate optimization is incredibly exciting and holds immense potential to transform how we tackle these complex challenges in general. Let's start with drug design. Traditionally, discovering new drug candidates has been a time-consuming and resource-intensive,
very costly
process, indeed. But here's where AI comes in to pretty much revolutionize things.
Yeah.
Imagine this: genetic chemistry methods where AI models design novel molecules.
Right.
These models sift through vast amounts of data to predict which molecular structures are most likely to succeed in binding to a target protein. And once predicted, these models can be synthesized and tested in the lab. This not only speeds up the discovery process, but also broadens the scope of what we can explore, potentially uncovering treatments we never thought possible. Now, this was the generation part. Now, when it comes to drug candidate optimization, let's say you already have a candidate.
Yeah.
With predictive models, we can simulate how changes to a molecule structure might impact its efficacy, toxicity, and pharmacokinetics, right? What the body does with that, later. This helps us make informed decisions about which candidates to move forward with, significantly reducing the risk and cost associated with drug development. Imagine having an AI system that can suggest the best modifications to a molecule to improve its performance in docking studies, as in a ligand binding to a protein. This is not science fiction anymore. It's becoming a reality, and there are tools already doing that. And what we are doing is to enhance this process with AI to make it, easier to orchestrate, essentially. At Cresset, I mentioned about our products, Flare and Torx. So we are integrating AI throughout our entire drug discovery lifecycle products. Flare is CAD, so computer-aided drug design. And Torx is for DMTA. DMTA is design, make, test, analyze. These are being augmented with AI capabilities to provide researchers with data-driven insights and process optimizations. We are also leveraging AI for orchestrating existing product features, allowing end users to interact with our tools through a natural language interface using chatbots. For example, they can ask our chatbot to write Python code using our software library for Flare.
Nice. You
don't need to know about that. You don't need to know the library at all. Or you can request a multi-step operation to be carried out automatically. Download this protein, prepare it with pH 8, and then do docking and show me the results. And then, suggest me insights. This not only enhances productivity, but also empowers researchers to focus more on the science and less on the technical details. And that's the main benefit, really.
Yeah.
Importantly, while doing all of this, we prioritize responsible AI. As we develop these advanced tools, we ensure that our AI models are transparent, fair, and ethically used. As I mentioned before, this is crucial for maintaining trust and ensuring that the benefits of AI are realized responsibly.
Responsible AI.
Yes.
I mean, there was actually a barometer done by a Canadian research organization. I can't remember the name of them, which is poor, but they did a sort of global study on how people trust AI and what people think of it, its acceptance, and it was low. It was really low. And actually, they were talking about how AI and biotechnology, and they mentioned things like drug design, drug discovery, protein design, and people felt a little bit concerned about that. So talking about responsible AI, I mean, from an expert like yourself, talk to us about what are the challenges here when building responsible AI, and things like hallucinations and ensuring transparency in AI models.
Absolutely, Kieran. You hit on a hot topic. Navigating the challenges of generative AI can be tricky, but not impossible.
Mm-hmm.
Let's dive into the deep end with hallucinations and transparency.
Mm.
So picture this: you are chatting with an AI chatbot, and suddenly it starts spouting facts about a unicorn being the national animal of Scotland. Well, that's actually true.
It is, yeah.
But sometimes AI can come up with stuff that's just as mythical, but not true at all.
Yeah.
Those are the dreaded hallucinations. They happen when AI starts making things up, not based on any data you given to it. It's like your GPS insisting there is a road where there is just a field.
That's happened to me.
And it can be a real headache, especially in our world where precision is the name of the game.
Yeah, important, to say the least.
Yes. So now, to keep our AI on the straight and narrow, we don't feed it with experimental data. That's not our job as a software provider. We don't have data. Instead, we got these guardrails, sort of like bumper lanes in bowling, to keep things on track. We use well-established AI models to start with, and have built-in checks and balances to ensure the AI's output makes sense in the real world, even though we don't handle customer data ourselves.
Right, okay.
We aim to make these systems as deterministic as possible, meaning they give you the same output no matter how many times you perform that action. And this is important because AI models are probabilistic. That's how they are built.
Yeah.
Techniques such as retrieval augmented generation, RAG, help in this regard by grounding AI outputs in a solid base of factual information, thereby reducing the chances of hallucinations, enhancing the reliability and transparency of the predictions. Now let's talk about transparency, which you also asked about. Let's face it, most AI models are like magicians who refuse to reveal their tricks.
Black box.
Yes, but in the pharma and agri-biz, you can't have that.
No.
People need to know how the rabbit was pulled out of the hat. While we can't make the AI spill all its secrets, we do aim for the next best thing, making it as clear-cut as we can. We are talking techniques that anchor AI's answers in facts. So there is a traceable path back to a reliable source, ensuring that the AI's thought process isn't just a roll of the dice. Right? Plus, we are super pumped about our new move. We are adding a responsible AI officer to the squad. This person is like the referee, making sure the AI plays fair and stays transparent. They keep an eye on things, run regular checks, audits, make sure we are all playing by the rules of the game. They'll be close to the legal aspects of what's going on in the world in terms of how it relates to our AI models. It's all about making sure our AI is as upfront and honest as a Boy Scout. Right. So in a nutshell, we are all about giving our customers the most crystal clear, mistake-free experience. We want them to feel like they got a trusty sidekick in our software, an assistant, not a mischievous genie out of the bottle that can do, tricky different things, unexpected things. And that's I think the Cresset AI way.
Yeah.
Keeping it real.
Yeah.
With AI.
No, this AI more generally, and AI ethics, the alignment problem, and some of the other more pertinent ideas that relate to this. These are things that really picked up in importance. Maybe 2015 onwards. There was work done before that, but we've now realized, especially when we're getting to the point, like you're saying, you guys are working on designing molecules that will make medicines and drugs. The stakes are so high. So having that drilled in across the business, the way you work, and as a priority, and then having a chief, a C-level exec dedicated to making sure this happens. That's really impressive stuff, and that's really, really awesome to see, because I think the mantra of go fast and break things, it's great, but sometimes we need to make sure that we don't break things, and this is one of those things we need to not break. So yeah, that's really, really cool to hear about. And I think lastly for us, and perhaps this is more philosophical, right? But it's interesting. Do you think we will ever achieve artificial general intelligence, or AGI?
Thank you, Kieran. That's a very intriguing question. It's one that sparks a lot of debate and curiosity within the AI community and beyond. And it's not an easy question.
It's a hard question.
Artificial General Intelligence, or AGI, refers to a type of AI that can understand, learn, and apply knowledge across a wide range of tasks at a level comparable to human being.
Right.
Unlike current AI, which is specialized and excels at specific tasks, AGI would possess a general cognitive ability. Will we ever achieve that? It's really hard to say definitively. On one hand, the rapid advancements in AI, especially in areas like deep learning, natural language processing, and generative models, suggest that we are continually pushing boundaries of what AI can do.
It's true.
And these developments hint at the possibility that AGI could eventually be within our reach. However, there are significant challenges and unknowns. Achieving AGI would require not only advancements in algorithms and computational power, but also a deep understanding of human cognition and consciousness. I think areas where we still have much to learn. There are also ethical and societal implications, that we need to consider, such as ensuring that AGI, if achieved, is aligned with human values and is used responsibly.
Yeah.
I mean, this is a big topic, and we can go deeper and deeper. Sometimes I think AGI is just a definition problem.
100%.
Intelligence is a definition problem. If we define it as something that can be measured by IQ tests, then yes, intelligence can be achieved, right? If you define it, well, I was thinking the other day, how would you define it from a physics perspective, right? Consider the second law of thermodynamics. It states that the chaos or entropy of the universe tends to increase over time. Because if you are transferring heat from A to B, some heat dissipates and is lost, right? And this is not reversible. So the entropy or the chaos of the universe keeps increasing. And intelligence is, one of the few things that put some structure in the universe.
Yeah.
We think, and by using some energy, we kind of put together things together. We reduce entropy locally, right? While the rest of the entropy, of the universe increases. So, are we going to call less chaotic objects and places in the universe a form of, that perform a function, a form of intelligence? If that's the case, then, the sun, some planets are going to be like forms of, intelligence, right? So how we define it? To me, intelligence is always, it needs to be attached to consciousness. For example, many AI systems today exhibit high levels of intelligence in specific tasks, like playing chess or diagnosing diseases without being conscious. They can, yes, process information, learn from data, and make decisions, but they do not have subjective experiences of or self-awareness. But this is not my definition of intelligence. To me, if AGI is going to be achieved, it needs to not only solve problems and perform functions, but possess a form of consciousness that allows it to be, that allows it to appreciate and understand its actions.
I have a very interesting small interjection for you there.
Sure.
Have you heard of it's a thought experiment by a philosopher. I believe they are called Frank Jackson, but I might be wrong. But it's called Mary's Red Room. Have you ever heard of that?
No.
Okay, so just really quickly, imagine hypothetically, and it relates to AI. It relates to exactly what you're talking about just then as well. So imagine there is a baby who is sort of, created in a way that she is born into a room where the only things that exist in that room relate to the color red. But the room is black and white, so she has all of the knowledge about the color red, and she grows up to be this scientist, right? She grows up to be this scientist, and she learns everything there is to know about red without ever seeing it. She knows about the waveforms, how it makes people feel, what things are red, what is not red. She spends her whole life, and she gets to the age of, let's just say, 30 years old, where she is, for all intents and purposes, an expert on red. And she's allowed out of the black and white room, and she opens the door, and she sees a strawberry, and it's red. Now, does Mary experience or learn anything new about the color red? That's the idea, right? Is intelligence, does this phenomena, is this a uniquely human thing, or a uniquely, this idea of consciousness? Does experiencing something, what does that mean? I think that relates to exactly what you're talking about.
If you think about it, throughout human history, we evolved and, we got better, more intelligent, hopefully, through our experiences. If you touch a hot stove, it burns, and then you tend not to touch it again. You learn a lot from experience. But then we started to, write things up, and then from generation to generation, we started to learn from these writings, theory, top-down approach. So we have bottom to top and then top-down, right? And we can learn both ways. With LLMs, it's always we point them to something they learn, they pretend to learn. And it's much harder for them to learn from their interactions, from experience, and to generalize these and to apply this new knowledge on things that they haven't seen before, right? That needs to be solved. If we are ever going to be achieving AGI. But maybe to link this to our conversation and what we do, at Cresset, we are focused on leveraging AI to solve specific impactful problems in drug discovery and optimization. Mm-hmm. So I'm looking at AI from a pragmatic point of view. Our goal is to create sophisticated tools that empower researchers and enhance productivity. While the idea of AGI is fascinating and certainly worth exploring, our current mission is to harness the power of AI to make tangible, positive differences in our field, right? In the end, whether AGI will be achieved remains an open question, but the journey towards it is already driving incredible innovations and insights that benefit various industries, including our own. And it's an exciting time to be part of the AI revolution, and we are eager to see where it leads us.
Yeah. You know what? And I think that's a really, really great place to end this as well, because I think if people leave this with any one idea and you take anything away from this, it's that these advancements, the innovation that is being made in technology and computer science, but machine learning and AI generally, and generative AI specifically, might really change the world going forwards. And we talk about drug discovery, biotechnology, medicine, healthcare, all of these different like climate change, agriculture. The possibilities they're endless, and it's companies like Cresset and people like you driving that forwards. It's a really important part of what we're doing. So yeah, Mutlu, it's been an absolute pleasure talking to you today about this. No, a real pleasure. I've really enjoyed this, and I hope everybody else has as well. So yeah. Any final thoughts from you?
No, thank you. I really enjoyed our conversation. Thank you so much for having me, Kieran. It was a pleasure to discuss our exciting work at Cresset and share our vision for the future of AI in drug discovery. I look forward to more such conversations. Have a great day.
Thank you, and thank you very much. Have a great day, everybody. Goodbye.
Bye-bye.